Okay, so in this video I'm going to talk about a different type of rational function that you might see that's called a complex fraction. So complex fractions, they look really ugly, but they can simplify down to some pretty unique things. So I'm going to show you what a couple of these look like, but you will see them from time to time. So let's say that I have, let's see, let's do a 3a on the top, and I want this divided by a squared over x minus 1, and I want that divided by a minus x minus 1. Okay, so pretty ugly. But the first thing that I'm going to do is I'm going to simplify the denominators of the fractions on the top and bottom here. So if I want to combine these two terms, got a squared minus x minus 1. That's going to give me an a squared minus x over x. Okay. And then for this term on the bottom here, I've got a over x minus 1. And when I combine those, I get an a minus x over x. So essentially, I can rewrite this fraction as 3a divided by a squared minus x over x, and then divided by a minus x over x. So actually on the top, we have a complex fraction in of itself, because I can write this as 3a over 1 divided by a squared minus x over x. So the thing is, this is still a fraction, which means that we're dividing the top and the bottom. So this is the same as me writing 3a over 1 divided by a squared minus x over x. And I know that if I divide two fractions, this is the same as me writing 3a over 1 times x over a squared minus x, because I'm multiplying by the reciprocal. And so when I carry out this operation, I end up with a 3ax divided by a squared minus x. There you go. So that's going to be the top, okay? And now for the bottom, I've got the a minus x over x. So that stays the same. And so I end up with a 3a divided by a squared minus x divided by an a minus x over x. So again, even though I got fractions on top and bottom, what I'm really doing is dividing these two fractions together. So this is the same as me writing 3a over a squared minus x divided by a minus x times x. And again, since I'm dividing, it's the same as me multiplying by the reciprocal of the second fraction. So I can rewrite this as 3a over a squared minus x times so this is times x over a minus x, because I'm multiplying by the reciprocal. And then I end up getting, this is a 3ax here. So I end up getting a 3a x squared on the top divided by a squared minus x over a minus x. And so if you want to, you can factor out the a squared minus x as conjugates. And I think I'm going to do that just so it's fully factored out. So this complex fraction up here at the top, whenever you perform the complex fraction operations, you end up with a 3ax squared on the top divided by a minus the square root of x times a plus the square root of x times, wish I can get rid of that, but times an a minus x. So I'm going to clear off my screen a bit. So I'm going to clear off the screen. So I got 3ax squared divided by a squared minus x times a minus x. So, and then the last thing that I can do is I can factor the a squared minus x on the bottom as a pair of conjugates. So I have 3ax squared on the top divided by an a minus the square root of x times a plus the square root of x times a minus x on the bottom. And now this thing is completely factored and completely simplified. Alright, so let's say I had this complex fraction right here. So I've got 1 over 2x minus 3 minus 1 over 2x plus 3. And that is divided by 1 over 2x minus 1 over 2x plus 3. Okay, so the first thing I'm going to do is combine the two fractions in the terms on top and bottom so that I get just a singular fraction on top and bottom. So the common denominator for the top is going to be 2x plus 3 times 2x minus 3, because that's how I get the least common multiple, by multiplying the denominators. And then I'm going to have a 2x plus 3 minus a 2x minus 3 on the top. And on the bottom, I'm going to have a common denominator of 2x times 2x plus 3. And on the top, I cross multiply here and I get a 2x plus 3 minus a 2x. Alright, so I'm going to combine like terms whenever I can. So on the top, I've got a 2x minus a 2x. So those cancel. And I've got a 3 minus a negative 3, so that gives me a 6. So on the top of the first fraction, I have a 6. And this is divided by 2x plus 3 times 2x minus 3. Now for the second fraction that I have a 2x minus a 2x on the top. So they cancel out, and I'm just left with a 3 over 2x times 2x plus 3. Okay, so now that I have just a single fraction on the top and bottom here, what this actually means is I take the top fraction, 6 over 2x plus 3 times 2x minus 3, and I'm dividing it by the bottom fraction. So this is divided by 3 over 2x times 2x plus 3. And again, I can rewrite this as multiplying by the reciprocal. So I've got 6 over 2x plus 3 times 2x minus 3 multiplied by 2x times 2x plus 3 divided by 3. And now to multiply fractions, I just multiply straight across. So when I do that, I end up with a 12x times a 2x plus 3 on the top. And on the bottom, I've got a 3 times a 2x plus 3 times a 2x minus 3. Now here's the fun part. This is where I get to cancel stuff out. So I can cancel out a 2x plus 3 on the top and bottom. And 12 over 3 reduces to just 4. So my final answer, what I'm left with, is 4x divided by 2x minus 3. So you can see how something really ugly can turn into something that's a lot easier to look at if you know how to use the operations for fractions and how to work with complex fractions. So the name of the game for complex fractions is the same as any other thing, it just looks a little bit different. So if you have two fractions on the numerator and denominator, I would combine them. And then once you have a singular fraction on top and bottom, then it's just a matter of dividing the two together, because that's really what you're doing. It's just whenever you have a fraction, you're dividing things. So if you want a more general form, so if you have some number over another number and you divide it by some number over another number. This is the same as me saying a over b divided by c over d. And again, when you divide fractions, you can multiply by the reciprocal and get the same thing. So I have a over b times d over c. And then to multiply fractions straight across, you just do top times top, which is going to be AD, and bottom times bottom, which is BC. So this is the general formula for the procedure of how to do complex fractions, okay? So I hope this video was helpful and that you can use it in your future math classes to make the calculations a bit easier and the numbers nice to look at. So thank you guys for watching, and I'll see you guys for the next video.